Okay, pop fly, a pop fly. Okay, so let's draw a picture of this. So this, again, this guy's going to go up and down. It's a symmetrical thing. It's being caught at the same height that it was hit, right? So it'll spend half the time going up, half the time going down. The velocity at the top is 0, okay? And we know that it goes 21 meters high, 21.0 meters high, right? Now, what we're going to do is we're going to set up this equation, but we're going to go from here, from the ground to the top, okay? So let's go ground to top, okay? So at the top, the final velocity is going to be 0, okay? We know that the top is 21 meters above that, right? The velocity at the top is 0 because if it's not 0, it's not at the top, is it? And then our acceleration is negative 9.8 all the way up, right? Okay. Which, of course, we probably have a positive initial velocity. And the acceleration's opposite that, so that means on the way up it's slowing down, right? This makes sense. All right. Okay. So let's see, we want to find, it says, what was the initial velocity? We would use, to find the initial velocity, I guess we'd use no t. So let's do that, okay? So no t is this guy, vf squared is vi squared plus 2ax. Let's plug in the numbers here, right? So vf is definitely 0, right? So 0 squared is vi squared plus 2 times negative 9.8, right? Times positive 21, right? Okay, we can do this. So now we've got 0 equals vi squared plus, and then 2 times negative 9.8 times 21 is negative 411.6, right? And of course, the first thing we're going to do when we want to solve for VI is we're going to add that to both sides, right? So that becomes 411.6 equals VI squared, right? So now we can solve. We can square root this and get the absolute value of VI, right? VI, the absolute value of it is the square root of 411.6. So literally, I'm going to go second square root, and then I'm going to go the opposite of the answer. And I get 20.287. Now, it could be going down to 20.287, but I think definitely it's going up if it went up, right? Okay, so I'm going to say that the initial velocity is 20.3. And I think that's positive. Because it went up, right? Sorry. Okay, so then it says, what total time did it spend in the air? Okay, there's really no way around using that answer because we don't have an equation to give us the time without the initial velocity. Okay, so I'm going to use this guy. VF is VI plus AT, right? So 0 is our final velocity equals 20.287. Notice I'm not using the rounded value. I'm going to use the exact value, right? Plus negative 9.8 times the time. All right. So then that becomes negative 20.287 equals negative 9.8 times the time, right? And then I just divide that. Okay, so divided by 9.8. I get 2.07. So the time to go up is 2.0702 roughly, right? Seconds. That's the time up, right? The time, this is up, right? Time to go down is the same time, right? Down would be 2.0702. So I'm going to multiply this by 2, right? So times 2. Total time in the air. Right, notice it asked for the total time, right? Total time is 2 times 2.07 is 4.14 seconds. Yeah? Okay, so just remember, if you figure out the time to the top, the total time in the air is twice that, okay?